Hi, welcome to a video from Robojax. In this video I'm going to explain the usage and calculation of resistor and pin configuration for the 7-segment LED display. We have either 1, 2 or maybe more digits of a 7-segment display, but there are one more characteristic, and that is if they are common cathode or common anode. Depending on the type of application, you might use different type of 7-segment display. So here we have this is called 7-segment display because we have 7 pieces of LED, or we have 7 LEDs here. So 1, 2, 3, 4, 5, 6, 7 segment, and there is also a decimal point. So let me show you on the diagram. So this is a diagram, and the top piece is called A, and so for B, C, D, E, F, and the middle one is G. So DP, decimal point. In this case, we have LEDs arranged in this way in this package. So A, B, C, D, and these are, this side of diode is called anode, and this is called cathode. So the cathode in this case are common, which means all of the cathodes of these 8 LEDs are connected, so we just need one wire. But on this side we need separate wires for each to turn them on individually. Here one LED is for the decimal point, this is also an LED. So this is the other one, this is called common anode. So anode is common, and then cathode are, which is the negative, this will be connected to the negative, they are separately. So we bring the positive here and the negative will be connected here through some means, or maybe Arduino or some other circuit that connects it. So this will be turned on each of those, and it will display something. So for example, to display 1, this will be on. For 2, A, B, G, E, and D will be on, and so forth. So you know that. Let's look here. So these are the pin. So pin 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. So if I put this on my breadboard, I've already inserted. So pin 1 starts here. So 1, 2, 3, 4, 5, and then go here counterclockwise 6, 7, 8, 9, 10. So you count it that way. And this is also the same, but the difference is this is common anode. Okay, so this is common cathode, and this is a common anode. And also we have 2-digit display. The 2-digit display, the number of pins does not increase. So what it does is we have one common anode or cathode. In this case, this is common cathode for 1 digit, and we have also another common for this one. So we have, this is 7 plus 1 is 8. And also we have 7 plus 1 is 8. So we have only 8 pins for all of those. Depending which common is activated, this will be turned on or off. So which I'm going to connect next. This one is common cathode. So the cathode of this one is common, as you can see on the screen. So the cathode is common, which is the negative side. We have all these common cathodes, so the negative is common and the positive will be connected to different digits to turn this on. This is common, as you can see on the screen. So pin number 3 and 8 is common. So this is, as you can see, I'm counting pin 1, 2, 3 right from the edge, 1, 2, 3. So this is common, and this positive, this is already 2 volts. So I'm connecting it to any of those. So if I connect this to 1, as you can see here, number 1, okay, number 1 will turn on the E. So this side is E. As you can see, the E is on. Okay, so now if I connect this to the second one, you can see the D will be on. So 2 is D. And also if I connect it to the fourth one, it's C. So 4 is C. And then here the decimal point. 8 is common, so these are connected to each other. 8 is the middle here and the middle on this side. So 2 pin on this side and 2 pin on that side, or the actual pins. So the middle one is common. So and so forth. So the last one is here, which is the G. So you can see G is number 10. So this is the middle one. Now let's look at the common anode. So this is common anode. So this time for the common, I'm going to use this one. So the red is now common, and the negative will move between the pins. So you can see here now the digit E is on, D is on, C decimal point, and this is pin 6 again. So just remind you, pin 6 is B, so that is B. And also I've created this layout here, 1 2 3 4 5 6 7 8 9 10. You can download it from my website, robojax.com. So the link is provided at the description. Okay, so then I'm gonna tell you if your voltage is not properly adjusted. I'm gonna give you the explanation on how to calculate that. Okay, now let's look at the 2-digit common cathode LED 7-segment display. So this has a 10 pin, so it starts from 1 to 5 and then 10, the same way 1 to 10. But here the common is for each digit separate, and then we have the other pins are common. So let's have a look at the. So when I insert this here, pay attention that we have empty spots. So after the 2 spot, the third one starts, and then 2 in at the end is empty. So when I insert my pen, so this is so that I have to skip 1 2 and then start from here. At the end the 2 is also skipped, and here 2 is also skipped. So now let's look at the diagram here. So we have 2 digits the same way, side by side, decimal point A B C D E F G. So here the common cathode, so this is the positive, and the cathode is the negative. So pin number 10 is A, and B is 9, C is 1, D is 4, and so forth. But if you want to turn the digit 1, so you have to connect the common to 8. So this is digit 1. Now let's turn it on. So 1 5 here, this is 6, so that skip from the 2, that is 6 7 and 8. So now I'm connecting at 8 and 2 more pins left, as you can see here. So now to turn the digit A, as you can see on the diagram, I have to connect it to the pin number 10. So that was 8 9 and then 10. 10 is for 8, 9 is for B. So if I correct 9, that's AB. And on the diagram, C is in 1, so I have to come here at 1. That is A, B, C. That is C, as you can see on the diagram. D, however, is at 4, so that's 1 2 3 and then 4. That is D. E is at 3, so that is E. And then F, as you can see on the diagram, I created this diagram because I couldn't find it online. F is at 6, so 5 is here, 6 should be here. And then the same way, by the way, if I move this common to the next one, so the second digit F will be activated. And then G, as you can see, is at 5. So if I move this to 5, 5 is here, so G is activated. Now if I move this, you can see on this diagram, if I move this to 8, so this will be turned on. Okay, so let's look at this. This is for the single digit that we have. Here it says the forward current is 20 milliampere, and we have some other characteristics. This is the model that I have. So the voltage, the VF here, it says forward voltage is 2.2 volts, and that's the current. So we need these two important things, and then we also have to know our main source of voltage. This can be used at 3.3 volts with Arduino, or 5 volts with a USB connector, which Arduino has. but for different voltages you can do the same calculation. So here is how it works. The IF, refers to current and F is forward. So forward current is 20 milliampere, which you can write it as 0.02 ampere, and then VF, forward voltage, this is a typical 2.2 for this one. So each LED is a diode, it's a light emitting diode, and they are set with a resistor to limit the voltage, or voltage divider as well. It will work as a voltage divider. So I put the values here. So the current that passes through here is 0.02 ampere, and the resistor is here, and the LED forward voltage is 2.2 volts as it says here. So that's 2.2. The formula is this: V input, the main voltage that comes here, either whatever you have, 3 volt, 5 volt, 9 volts, V input minus V forward divided by current. So here is 5 volts. Let's say I'm connecting 5 volts minus 2.2 divided by 0.02 ampere. That's a current. So you need to put 140 ohm resistance on the path. So here is for this example. So 3 is common cathode. And then if I connect this, so that's one of the segment is on. So if you want to use your resistor, as you see on the diagram, each diode, each LED needs its own resistor. So you need to put the same number of, this is 7 segment plus the decimal point if you use it, otherwise 7, you need 7 resistors. So each will have its own. Because this is common cathode, you put your resistors in anode here on this side, and the voltage will come and go through the resistor as shown here. So we will put the resistor here at anode. Okay, so now look at the circuit that I have. This is just an arbitrary resistor, so I'm gonna put it here. So that resistor, so the positive here comes through a resistor. So this line is all connected, so the positive comes, and from here I have to put a wire, a jumper wire, to connect these two. Of course, I have not done the calculation depending how big it is. You see it's very dim. Now it's preventing all the voltage to come here, so some voltage drop appears as the current passes through. So this will prevent the voltage, the full voltage, to come here, and it will absorb some of the voltage. So that's why we call it voltage divider. Okay, that's it, guys. If you like this video, please thumb up and also subscribe to my channel if you haven't done so far.